welcome to Learn Extra Live. I'm Katleho and this is Iti. How are you, Iti?
Hello, Katleho.
Are you good?
I'm all right.
Good.
Hello to the viewers out there.
Hello, guys. So today we are doing maths because it's Monday and by now we are on the grade 11 show. So welcome, grade 11s. What will we be doing today?
We'll be doing revision of grade 11, the whole cross-section of function, Amplitude functions.
Okay, then functions is good. I know they enjoy functions and it's a good section to work through, hey?
Yeah.
Okay, thank you.
We'll see how I make it easy now.
Thank you.
All right.
So, of course, because I mentioned that it's Monday, I hope you guys haven't forgotten already if it's been a long day for you, but we have prizes. We have our Casio calculator as well as the Casio labeler. So, as you guys know already, it goes to the most awesome, most fantastic, most energetic, most everything mindsets on the page. And the page that I'm talking about is our Facebook page, which is facebook.com/learnextra. And our Twitter handle is @learnextra. Make sure, guys, today functions revision is going to be yours, guys. So work through it. Be patient with yourselves. Also, don't be that patient that you actually fall asleep on the couch, because we don't want that. We want you guys focused and alert. Thank you again to Liberty for bringing us such an awesome show. Over to you, Iti.
Thank you, Kateo. Yes, we're going to do the whole cross-section of functions, and I want you to look at it as periodic functions versus non-periodic functions. And starting with periodic functions. Periodic functions, by periodic I'm referring to those functions, basically trigonometric functions. Typically the sine x, cos x, and tan x. All right, so we are going to look at what are the defining features. Just a bit of revision. Let's recap a bit here. The defining features of a sine graph, cosine graph, and a tan graph. Let me take a sine graph first. If I had y equal to sine x as a parent graph, if we draw this, I'm not going to go through the whole thing of tabulating the values. I'm just going to draw it right away. I'm sure you know the shape. It starts off by increasing, then decreases until 360. And of course, there is the other half this side, repeating the same form. So you will notice, obviously, you know what is the period from 360 to 0 degrees, minus 360 to 0, up to 360 degrees. And this is our x, and that is our y. Now, two features that you have to remember. You can see that this is actually a waveform which repeats itself after every 360 degrees. And that quantity we call a period, where we say a period for a sine graph is equal to 360 degrees. This means every 360 degrees, the graph repeats its shape, the S shape in this case. So notice that it started off by increasing, then it was 0 there, and it became negative slope there, and 0 again, positive slope there. All right, so at this point, the highest point is called corresponds to 90 degrees. Then it comes back to 180 degrees. Then over there is 270 degrees. You'll remember that that highest point corresponds to a value of y equals to 1. And on the other side, that corresponds to a value of -1. You can actually look at it as the peaks of the mountain and the valleys. That is the highest point and the lowest point. So there is infinite of them, depending on how far we decide to define our interval to go. So how do we find the amplitude? Now, there is the second defining feature, amplitude. Amplitude. The amplitude, we take it as the distance from the neutral line, which is right at 0, up to the highest point. In this case, the best way to look at it is to say the y at the maximum level minus y at the minimum divided by 2. All right? So what is our y maximum? Our y maximum is 1. We subtract minus 1, which is the lowest point. That divided by 2, it will give you 1 as the amplitude of this graph. I prefer to use this expression, note it, because this expression takes care of the graph, of the amplitude when you have translated it up or down. Because many people have looked at the graph and they find that, let me just give you a quick example to make sure we don't get into that trap. If this graph turned at, let's say, 2 there, and this side it's minus 2, the amplitude becomes 2. But then, if you have this graph translated, suddenly you've got a value that will, okay, let's say this is translated to somewhere there. Now, suddenly, if this is 3 units there, and this is minus 1, you have to basically see that this is not symmetrical about the x-axis, and therefore, this becomes a handy formula to work out the amplitude. All right. More than that, what's the other feature that I want to point out there? Yes, we need to, for any graph, we need to define the domain and the range. The range for a sine graph, you're going to write it as y less than 1 but greater than minus 1. That's our range. Our domain, we have to define it as, in this case, in our case here, we chose from minus 360 to 360. Therefore, we write it as x greater than 360 degrees, minus 360 degrees, but less than 360 degrees. We could have chosen a different interval there. So that's the x interval where your graph exists. That's what your domain is. All right. So that was the sine graph. Let's move on quickly to the next one, which is y equal to cos of x. You'll notice that these are the parent graphs that I'm starting with. Later on, I will basically do transformation on these graphs. That means scaling them up or down, or translating them, yeah. All right, let's see. In this case, you will remember the shape for this one. It's just like the sine graph, but it starts off by decreasing, then it increases back to a level 1. So I could have continued that on this side up to 360 minus 360. That is 0 degrees there, and that will be 360 degrees. So again, the period for this graph is going to be the same as that of a sine. Over there, that's 270, and that is 90 degrees there. All right, so the minimum value becomes minus 1. Let me just circle that. So the same way we found those, we described those features for the sine graph, it applies to the cosine graph. The period is 360 degrees. You can see this shape started from minus 360. When it got to 0, it started repeating itself until 360 degrees. All right, so that was the period. And then the amplitude is, we still find it the same way. The maximum is 1 over there, and minus 1. If you do it the same way you did with the sine graph, you end up with the same amplitude of 1. And the range and the domain is exactly the same for the sine and the cosine. So what's the difference between the two? The one starts off at 0, decreasing, whereas the other one increases starting from 0. Okay, I'm talking about the slope. All right, So if we move on to the next one, let's just cover, because there are only three basic functions that you have to worry about. So for a tangent graph, so let's go y equals to tan of x. There's a slight difference here between, it's got what you call asymptotes. So you will have at 90 degrees and every other odd multiple of 90 degrees. Let's see. Another odd multiple of 90, that is 3 times, is 270 degrees. So every odd multiple will have that asymptote. Minus 90 degrees, so on. All right, that's 180 there. And 0 degrees. So your graph is going to look like that. All right? Down and up. So every odd multiple, as you can see, you've got this graph, repeating itself. So between 90 and 270 is 180 degrees. So that shape repeats itself every 180 degrees. From minus 90 to 90 is 180 degrees again. So the period for this function, is therefore going to be, let's go, the period for a tan function is going to be 180 degrees. So it repeats itself every 180 degrees. All right. So remember I talked about asymptotes. I just want to pick on all the features there. So it's the period. It also has, in addition, asymptote. Infinite of them. I mean, there's an infinite number of them, depending on how far you have defined your interval. Asymptotes at odd multiples of 90 degrees. All right, and do we have an amplitude? No, we do not have an amplitude. This does not have the peak and the valleys. It does go right to the most negative number and the most positive number up there. So you don't have an amplitude in this case. No amplitude, just to emphasize. No amplitude for this one. Okay, so 2 features important there. You've picked them up. Let's move on to, yes, those are the basic functions. Let's move on to a bit of transformation of these functions. We're going to take first a sine graph and do what? Scale it up. And what do I mean by scaling it up? If you take it that this is y equals to that, y equal to 2 sine x, if it started off in your table as, let's say you had that, and that was y equal to sine x, you now scale it up and say every y value you're going to multiply by 2. So in your table, the values that you get over there, you then double them. Let's see what symbol can we use there. Okay, so 2 times here. All right. So what it means, therefore, is that your y values, typically, if you had sine x, if it was previously at an amplitude of 1, that value must be multiplied by 2, and you end up with 2 times 1 equals 2. So you've actually scaled it up in the vertical direction. Okay, and the same would have applied there. If it was minus 1, then it becomes minus 2. All right, so the period is still the same. we're still at 90 degrees there, 0 degrees. Over there, it's 180 degrees. Over there, 270 and 360 degrees. Okay, notice that I've now chosen to draw this thing in the interval from 0 to 360 degrees. So this would then be a graph of y equals to 2 sine of x. All right. And Katleho, will we be able to get questions as we go?
No, it's fine. You can just carry on and we'll do the questions at the end.
All right. So let's move on to the next one. That one that I did was a sine graph, taking it from a parent graph, scaling it up by 2. By 2. Scale factor was 2 there. Now I'm taking a cosine graph, and I'm scaling it down by a factor of 2. 0.5 is the same as half. So we've got y equals to half of cosine x. So if I then draw this graph here, it used to be a cosine graph that starts at, let's say, 1 there. And in fact, let me use this, let me keep it dotted there. What's happening to my eraser there? Okay. All right.
Do you want to erase, E.T.?
Yeah,
you can just press the eraser
really
at the top, yeah. Yes, that's it.
there.
And just click on one,
All right.
and then you can erase. No, with the pen.
Oh, with the pen
Yes.
itself.
Oh, okay. Pick it again.
All right.
You
No,
know
it
this
doesn't-
board.
No, it doesn't matter. Look,
Okay.
Katleho, I'll use. Okay. Let me explain it this way. So from 1 unit as the amplitude, this thing is now every value of y, like we did with the cosine graph, is going to be reduced. If it was 1, it's going to now be half of that. Okay. So this used to be 1 unit there. Now it is half of a unit. The amplitude now has been reduced, scaled down to a half. So essentially that's what scaling up and scaling down is about.
Can we go for an
All right.
ad break, E.T.
I think
before?
let's go for an ad
Okay.
break, and we can continue from there.
Okay,
More
perfect.
transformation, more transformation.
Okay, awesome. So you guys heard that. We have so much more after the break. So for this break, just relax and we'll be right back, I promise you.